which is 50. Okay? And then it wants us to interpret what this slope means. Okay, so for every 1 it rises, which is cost, it runs 10, which is the number of text messages. So the cost of 10 text messages, because that's how far it ran, and it went up 1 at that same time, costs $1. So it's $1 for every 10 texts that you send. Okay. You can phrase that differently. Like I said, 10 text messages cost $1, that kind of thing. Okay, so for number 6, well, again, it crosses that y-axis, so I easily have b, which is that 360. And then I need to figure out my slope. In this case, it's going down instead of up, so I know my slope is going to be negative. And it went down, all the way down to 0, so it went down 360. And then it went from 0 over to 6. All right, and that simplifies. 360 does divide by 6. So in this case, my m is negative 60 over 1, or we could just write negative 60. So the equation would be y equals m, which is negative 60, x plus b, which is 360. And then I need to interpret what the slope is, what this negative 60 over 1 is. All right, so if it's up and down is the 60, and that's distance. And the distance is getting less. That's negative. It's getting smaller. And then going right is in hours. So for 1 hour, it's getting 60 miles closer. Okay? So when you're driving, you're getting 60 miles closer for every hour or something like that. Okay? Or you're driving 60 miles an hour, but we have to interpret that negative slope. And so that's why we're going to say closer instead of just saying 60 miles an hour. Now, number 7, I can see across that y-axis, but I don't know that exact point. Like these, you can see it put those points there. They were exact. This one is not. So I actually need to find my y-intercept, or use these 2 points and find my slope, and then I can plug it into point slope form. Okay, so let's do rise over run. Now it's going up, so I know it's a positive slope, and the y's go from 85 up to 95. So it's going up 10. But then how far did it run over? Well, it's going from 10 to 20, so it actually is going over 10. So obviously the scale of the dimensions this way is different than the ones going up and down. 10 over 10 is actually 1, so my slope is 1. And then I'm just going to pick one of these points and use as x1, y1. I'm going to use this one, x1, y1. And I plug them in. Y minus 85 equals 1 times x minus 10. Okay, now 1 times anything is just itself, so this is 1 minus 85 equals x minus 10. And you could solve for y to get it into slope-intercept form by adding that 85, or you could leave it like this. But once we start graphing things, we know we like it to be in slope-intercept form, so I'm just changing this one just to show you that we can. Equals x plus 75. So here's my equation. And I need to interpret that slope of 1 over 1. So for every 1 completed assignment, the percent goes up 1. That's how that works. So for every completed assignment, the grade percent goes up 1. Okay? Or the grade, sorry, just grade goes up 1%. That didn't make sense. All right. Now, for number 4, and let's see, we're getting ready to start using the graphing calculator here. The cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20. So I want to make a note that this is Chicago. okay? Where y is the total cost in dollars and x is the time in hours. The table shows the total cost to park in the parking garage in Denver. So this one is Denver. That's why I wanted to make a note, keep Chicago and Denver separate. Which city's parking garage charges more per hour, and by how much more? And that more per hour is your slope, okay? So we need to find the slope of this. And then we really just need to find the whole equation of this one, because then it does want to know in how many hours would they be the same. So I need to be able to set them equal to each other. So I need to find slope, and here's my y values. My y values are going up each time by 8. Okay, so m will be 8 over, and my my x values are going up by 1. So it's going to be 8 over 1. So in this case, my slope is 8, and I need that y-intercept. So we could plug in a point. We could plug into 43, but with tables like this, it's really easy. If it's counting up by 8, we can count down until x is 0. So this is counting up by 1, so if I go down by 1, I have 1. And I'm going to go down by 8, okay? And then if I go down by another 1, this is now at 0, and you would be at 27, because you go down by 8 more. Okay, so, I'm sorry, you probably wanted to know that this was 35. So 43 down to 35 down to 27. So here is B, there is M. The equation for Denver is y equals 8x plus 27. Okay, now that was just so we could answer this first question. So in this first question, which city's parking garage charges more per hour? Well, this one charges 8 per hour, and this one charges 15. So it's going to be I'm just going to call this part A. It's going to be Chicago. By how much? Well, this is 8, and that's $7 more. So by $7 per hour more. Okay. Then question B here says, after how many hours would parking in both cities cost the same? So I'm going to take Denver's equation, and I'm going to take Chicago's equation, and since this is what y equals, I'm going to substitute this in for y up here and set them equal to each other. So I'm going to end up with 8x plus 27 equals 15x plus 20, and I'm going to solve for x. All right, so if I move all my x's to one side, I'm going to subtract 15x. So I get a negative 7x plus 27 equals 20. Subtract 27. Negative 7x equals a negative 7. You divide by negative 7, and x equals 1. And x was in time in hours. So at 1 hour, they are the same. The cost for parking is the same. All right, so now we need to go over some things about the graphing calculator. So here's a little picture, but I'm actually going to use a graphing calculator to show you the buttons a little bit. So let me zoom out just a smidge so you can see. Okay, so if we are doing linear regressions on the calculator, there's this button that says Stat. Okay, so if you push Stat and under Edit, we want to edit. Okay, so if I push Stat and then Enter, you see these two columns where it has L1 and L2. L1, let's move it over a little bit. L1 are your X values. L2 are your Y values. So when you're given a table just like this one right here, I could have plugged in 2, 3, 4, 5 in this L1 column and deleted all the rest. I have other stuff in there right now. And then in the Y column, you could have put 43, 51, 59, 67. And what we're going to learn to do would actually give you this equation right off the bat, since you already know how to find it. But we're also going to do some other things. Not only do we want that equation, but we need to do linear regressions to find best fit. All right. So there's a window button on the calculator. That window, it is just to adjust the scale in the window. And that's an and, sorry. And I hardly ever use that button. I use it more for graphs. I'm sorry, this got kind of blurry. Let's move this to the side, maybe it'll get clearer. Ooh, got worse. And now, if you push second and then the Y button, see that stat plot? Okay, that's to turn that on and off. So if you want to see all those points graphed on your calculator, you would turn it on and you could see them graphed. But a lot of times they'll be graphed on your paper, so that's not necessary. But just in case you want a visual of it, that's what you need to do. And then you turn it on, and then you just click the graph button, and it would show you. Now this stat calc linear regression enter. So this is kind of a big deal for what we're doing, and the stat edit is the main big deal. Okay, you have to do stat edit first, put in your values, and then you would push. So I already had something in my values. So if I push stat, if you control over and go to that calc, and then if you look, number 8 says lin reg and then a plus bx. Okay, that's a linear regression. You can scroll down and push enter, or we know it's number 8, so I can actually just push 8, and then I just enter through. You need to make sure this says L1 and L2, and then you scroll down to calculate and push enter. Okay, and it gives you all of this stuff. Okay, we're going to ignore R squared. We really care about the A, the B, and the R. Okay, now if you have to pay attention, this equation gives it to you as y equals A plus bx. And when we write an equation, we always write the bx plus that A. Okay, so when you're plugging things in, you just need to make sure you put them in the right place. Okay. So in this case, we're going to have y, and we want the bx plus a. So you need to remember, in this case, b is slope, and a equals the y-intercept. All right.